So welcome to AI for Busy Java Developers. This is a short version of my course on LinkedIn. The QR code, if you want to view that course for free, it's free for a month. So you can use that QR code. Okay, so if you're here and you know how to fine-tune a large language model, you're an advanced user, this is not the presentation for you. Okay, this presentation is for people getting started in AI, that are Java developers, and I'm trying to plan this for this is like your first introduction. And the reason why I'm doing that is because I've found over the past several years in teaching this material, and I've talked to people outside of the tech world. I've talked to CTOs. I've talked to partners for law firms. I've talked to a lot of my friends who are medical doctors, and we talk about generative AI, and they don't understand it. And you have the average person using a chatbot like as if it's a search engine. He goes, no, it's not. So I want to clarify some things, what specifically generative AI is, so then you're on the right road to learning these things. Because we're all learning bits and pieces about how to use prompts, and how to use fine-tuning and RAG systems. It's all like jumbled. I want to level set everybody so that once you listen to this presentation, hopefully that you know where to go next, what to learn next. Okay, now a little bit about my background, why I was interested in this. So many years ago, and you can tell from the color of my hair how long ago it was, in graduate school, a lot of you know that I'm a musician, and I've been a musician more than a tech geek. And when I was an undergraduate and even a graduate, I was interested in melodies, melodic styles, right? So it's interesting that if I can look at a style, how a melody flows, and figure out that style, then maybe I can use some random numbers to generate a probability distribution that reflects that melody. So we're going back several decades. So I analyzed a musical style and I created a new melody. That's generative AI. We didn't call it generative AI back then, we called it computer science. So now we're calling it generative AI. So let's talk about some of the topics that I want to cover. Now, I'm obviously going to go over this rather quickly. And when you have questions, let's hold the questions to the end, and we can go out in the hallway and discuss this further. So I'm going to go over really high level. Again, my point is that I want you to understand the basics, and then you can go off and learn about RAG systems, or learn about prompt techniques, or learn about this. But I want you to learn the basics first, and how this is way more important than just generating code. We're talking about way more important than just generating code. And a lot of us see there's frameworks for this stuff, right? We see the frameworks. We're framework crazy, right? We're Java developers, right? It's just another framework. I'll just plug it into my IDE and then I'm off and running. Really simple. And then you'll hear that from some of the vendors, it's a piece of cake. Not to worry about it anymore. Well, okay, and we know that it's fairly easy. And so it might be a little difficult to read in the back, but this is just like a one-page Java program without any library. You can copy-paste this into a file and say Java, name of this joke.java, and you're connecting, as long as you have an API key, of course, and we all know, when you have a REST API, you need an API key. It'll tell you a joke about Java. Less than a page of code. Okay, and then here's another example using the library, very popular and really nice library, LangChain4j. Less than a page of code. Pretty straightforward. This is not hard. It's not hard stuff at all. So this is probably a piece of cake. I can just plug it into my IDE or my runtime. This is easy. Okay, but the problem with this is that, let's say you're a musician and you're going to play an event, you're going to play a gig someplace, and you know all about your drum kit, and you know all about the fancy cymbals, and you know about the size of your bass drum and your tom-tom drums, or you're a guitar player or bass player, and you know all about your equipment, the pedals here, and you're in a punk band, and we're going to play the best gig ever. And you know all about your tools. You spend hours and hours learning this tool, and you go to the gig, and that's in your audience. You didn't understand how to use your tools for that use case. So there's a problem. Okay, it's nice to use these tools, right? We are Java programmers, so we know we're framework crazy, right? We love frameworks. But you have to understand what you're doing. AI, you cannot just plug something into an IDE or your runtime environment and say, like, I'm done with it. I just know how to generate a prompt, I'm done with it. This is a different beast. So if you're creating an e-commerce system and you have like an e-commerce library, or if you're in medicine and you have a medical API, you have to know about e-commerce and you have to know medicine. If you're in investment banking, you're dealing with fixed income instruments, you have to know about fixed income research, right? You have to know about this stuff. It's the same thing with generative AI. You have to understand what's going on. You cannot just plug it in, because you're going to hit some serious problems. So we know it's becoming a big tool in the software development process, and we certainly have heard about, we've all used chatbots, right? And we know about, like, the IDEs are generating code, and we watch, some of these CEOs for big companies saying, like, you're all going to be out of jobs, which of course is total BS, right? Their companies are going public. They're trying to promote their company. So just, we're going to have AGI by this summer, and you're all going to be out of work. It's like, okay, it's total snake oil. They're just pumping their companies. So as developers, we have plenty of opportunity going forward. Our jobs are not in danger. Now, if we don't keep up with the trends, of course, then your job's in danger. If you didn't learn about IDEs like 10 years ago, 15 years ago, your job's in danger, right? And why are we in this field? Because it changes the whole time. This is what's cool about it. It's changing again. Change with the times, right? Change with the times. And we've seen, chatbots and code generation, and I showed you the APIs. It's a piece of cake, right? But you have to understand the foundations of AI and machine learning. Okay, so let's take a step back. So when I was dealing with melodies back then, being a musician, if you're a blues musician, you know about 1-4-5. I can talk to any other guitarist and say, like, we're doing a jam 1-4-5 in A. And they would know how to play with me. How is that possible? Well, they know the patterns. If I said we're doing jazz 2-5-1 in A minor, they would know that. Why? Because there's patterns. Why do animals know where to find food? Because there's patterns, right? If you play sports, offense and defense, patterns. I was in astronomy when I was in high school, right? So there's stellar phenomenon. When they become unstable, they explode, and they go down to a more stable state. That happens in business, right? In music, we had in the 90s, we had Kurt Cobain, and we had Elvis in the 50s. Great musicians, but what happened before that? There was the war for Elvis, and then there was the excess of the 80s. So there was periods of instability, then explosion, and then stable. So these are all common patterns. And I worked for investment banks. You may have heard of Lehman Brothers. So in investment banking, we're always dealing with correlation and patterns of trading. Again, patterns. So there's that word, patterns. Everything is a collection of patterns. Even in Java, what do? We collect things that are similar into classes. That's a pattern. So this is the basis of everything. It's all about patterns. So they're everywhere. They're not just in tech, but everywhere. So machine learning is all about patterns. Notice I didn't say AI. I said machine learning is about patterns. So we're recognizing patterns, and then we're predicting, like the weather, right? Like the weather, or you're at Amazon and said, like, you might like to buy this, or you're using Netflix, so you might want to see this movie, or Spotify, you might like the song, right? That's predicting or generating with generative AI, right? And we know back in the mid-90s, if you're a programmer back then, I guess that's not going back a long time. Back in the mid-90s, there's this famous book on software patterns, right? How many people have heard of this book? Right, yeah, most of you. Very famous book about software patterns. Well, this book was patterned on a talk by these two gentlemen, Kent Beck and Ward Cunningham, very famous computer scientists, on using pattern languages for object-oriented programming. So that was patterned in that talk 10 years before that. Now, 10 years before that, that talk was patterned on this book, A Pattern Language. This book had nothing to do with software. It was about physical buildings. So in this book was patterned on that. From buildings, from things that we built over centuries. So there's patterns beget patterns beget patterns. And we know that we have regular expressions. So how many of us use regular expressions in Java? Yeah, most of us. And if any developer, C programmer, C++ programmer, regular expressions, right? Where do they come from? Well, in the 40s, when they invented artificial neural networks and when AI first started the ball rolling, and actually, again, there's another pattern. So where did that come from? In the 40s, there was like artificial neural networks, there was recognition of patterns, there was the notion of mimicking a human intelligence. What happened in the 30s? Well, people just realized, can we apply mathematics to biology? That was the trend. And so this came out of that. So regular expressions, Professor Klein, who invented regular expressions, he said, wow, this AI stuff is really cool. I'd like to experiment with it. So what can I experiment with that I know? Well, text. Let me experiment using text patterns. So even back then, it was machine learning. So regular expressions were invented because of machine learning. Right? And then this gentleman came along in the 40s saying that everything is made up of patterns, and I would say extend that to the universe. It's all made up of patterns. Now, for definition purposes, and we should get this right since we're supposed to be the smart people on the planet, right? So we have AI. AI is, simulating human intelligence. You could argue whether humans are intelligent or not, but that's another discussion. So we have AI, and that's been going on for decades. We're writing programs in Prolog or in Lisp. We're writing rules in expert systems. So that's AI. A subset of AI is machine learning, where we're not doing explicit programming, is that the machine can recognize patterns. It can read data and detect patterns using numerical analysis techniques and statistics, right? So there's no explicit programming of actually generating patterns. And now with cloud computing, with GPUs and advanced data structures, we have deep learning. So deep learning is like modern machine learning. And now there's two important subsets of deep learning. There's predictive deep learning, like the weather, or Spotify, or Amazon, or Google search. That's predictive AI. It's been used for 20 years. Most of the money in AI comes from predictive AI. And of course, we hear about the buzz from generative AI, because that's the trendy thing, but the money is coming from predictive AI right now, by orders of magnitude. Now, over time, 5, 10 years, they'll probably be very similar, but there's generative AI. So these are subsets of deep learning. But of course, you're watching YouTube videos or you're reading something, it's Gen AI. Well, it's really generative deep learning, but nobody calls it that. So that's where the term Gen AI and predictive AI come from. It's really a subset of machine learning, deep learning, but nobody calls it that. And even now, some people call their products AI when they mean generative AI. I think Spring AI, right? I don't classify it as AI. That's generative AI. It's a cool tool, but it's generative AI. It's not AI. But we're going to focus on Gen AI since, of course, that's the hot topic, and that's what is getting everyone excited. So where can I apply this stuff? So one day I took thesaurus, and said, let me look up words that have patterns in their meaning. And I was kind of shocked how many words represent patterns. All these words represent patterns. So wherever there are patterns, there's opportunities to use machine learning. See, not all of these are tech-oriented, right? They're not code-oriented, but you can apply machine learning to any of these. That's really cool. There's a lot of opportunity. It's also scary because it can be subverted. But since we're all developers, let's find out where can we use it in the development process. So again, I said, like, let me think, what do I do on a daily basis? You know, what does a developer do? Okay, we start off, we write requirements, we do prototyping, there's a development phase, we do, you know, that's where we write the code, documentation, unit tests, then we deploy things, put things in production, and then of course there's the lovely aspect of maintenance over on the left-hand side. All of those boxes have patterns. In addition to these boxes, well, how many times are you searching at Google for something? You're searching on the internet for something, or you're searching on your local file system for something, or you have to go to a meeting, or a problem comes up that day. So I wasn't expecting this. We have to solve a problem, or there's emails, text, or status reporting, all this other stuff that we have to do on a daily basis. Where do you see code generation? There's only one box there. So when people say, like, your job's going to go away, it's going to be several years before that ever happens, if ever. Okay, yes, it can help with code generation, but there's so much other stuff that we have to do. And AI certainly has tackled code generation. I was seeing some cool demo downstairs, or this floor, with IntelliJ. That looks pretty awesome. And there's some companies now that are doing AI-generated unit tests. I think Diff Blue comes to mind as a company that does that. But what about the other boxes? So for the entrepreneurs out there in the audience, there are some greenfields to go after over the next 5 years. If you have some ideas and you want to start a company, all these other boxes have patterns where you can use language models to help with the process. So there's a lot of opportunity yet to come. So it's not just chatbots and code generation. There's so much more to come. And some of you, hopefully, are going to build startup companies that are going to go after some of these other boxes. So we're just getting started with this stuff. So again, this natural language processing, the basis of all this stuff, comes from the 1940s. And language models, early 90s. Again, it's nothing really super new. But in 2017, this paper, very, very famous comp sci paper, Attention is All You Need. So this was a new look at language models. And this so-called attention mechanism, which it wasn't the first time attention mechanisms were mentioned, but it was an advance, it was an enhancement of attention mechanisms. And what that means is that, you remember in grammar school when you're looking at sentence structure and you have someone's name and then you see like he or she, and your teacher would say, well, what do you mean by he or she? Well, I'm referring to this previously in the sentence. So the attention was back there. So there you're doing it as a human, but then all these other words, they have gravity, right? They have attraction to these other things. That's more or less attention. So now we've come up with algorithms for that. So this is a refinement of that. The big refinement, and we know this as Java developers, is that the algorithm was parallelizable. And we know that's a good thing, right? Because now you could do training. You could train a model really quickly. So not only you have large data, but now you could relatively quickly train a model. So this is a big breakthrough. So before 2017, there was ML, and then after, everything just sped up. Then, of course, over the past 3 years, ChatGPT got the general public's attention. So that's really exciting. And the way this works, again, since it's not a search engine, is that you have you have a neural network, which is basically a data structure with a lot of nodes, basically. And when you feed it data, so the neural network starts out with probabilities. And it starts out not with 0, because 0 is a legitimate probability. It starts out with random numbers. And then you feed it data. And what's the most likely path for this text to follow? It looks for patterns, right? So it figures out the gradient of where, if you start here, where are you going to go? Like water going down a hill. Where does it go? Well, because that's deeper over there, it's going to go that way. It follows the gradient. That's what a large language model does. I'm certainly simplifying it, but that's the basic idea. So all these different weights or probabilities are all these boxes, and we have talked about billions of boxes. And then you generate a model. So how many models do you think are out there? Anybody? You're cheating. So someone who's not a cheater. 20? 100? So there's 1.4 million. So if you go to Hugging Space, there's a link down there, huggingspace.code/models. Matter of fact, that's 2 weeks ago, 3 weeks ago. I bet it's like 4 or 5, 1.45. So this is like GitHub, though. I mean, on GitHub, there's a lot of projects. How many of them are useful or are successful? Very small fraction, right? So this same thing goes here. I mean, of all these, there's probably maybe 500 that are useful. There's text models, there's vision models, image models, there's audio models, but there's a lot, and they're trained differently. But you don't have a language model that's trained just for one thing, and that fits everybody on the planet, right? Because we're all diverse, right? It's just different things, not just for the application, but we have different cultures, right? Okay, so let's talk a little bit about language models. So when I talked to this one person that I know who's a partner in a law firm, and she used a language model for the first time, I think it was ChatGPT, and she was using it like a search engine. It's not a search engine. Don't use it like a search engine. While it does understand the patterns out there, it's trained on the internet. For better or for worse, it's trained on the internet. So it's trained on a lot of text and a lot of images. We know it's trained on a lot of images of cats, because there's a lot of images of cats out there. But it's trained on the text out there. But it's not a search engine. Can it be used with a search engine? Of course, yes, that's a great application. It's a great application to use for a search engine, with a search engine in an architecture. But it's really a pattern recognizer and a text completion tool. You teach it, to recognize patterns. That's where the word learning comes from, machine learning. And then once you have the model, then you use the model. So what you give it, this text is called a prompt, right? You probably have read, like, you give the language model a prompt. So the prompt is steering the language model. It's not updating you already have a model, so the weights are sort of baked in, but now you want to guide the completion through the neural network. And your prompts are guiding what's happening in the neural network. So your prompt is really important. Your prompt is really, really important. And it's not just your prompt, but the stuff around your prompt, right? And because we're dealing with a new type of technology, right? We're used to, like, you have a system, input, output. Same input, same output. Same input, same output. We've done this for like 60 years, right? Same input, same output. Now we're dealing with non-deterministic systems. We're dealing with non-deterministic systems where you have the same output, same input, and you may get a set of output. And you may get a totally wrong output, a totally unexpected output. So this is a big complication for enterprises. How do you deal with non-deterministic systems? Right? Enterprises are not used to this. How do you deal with non-deterministic systems? So it's an interesting problem. And when a language model gives you something unexpected, the common word is hallucination. I mean, the correct word, if you have a neuroscience friend and you ask him about this, it's not hallucination, it's called a confabulation. That's the correct word. But everyone says hallucination because that's the popularized term. But it's really the proper term is confabulation. So a language model is giving you a statistical output based upon the things it learned, and it may give you something that you want that's useful, or it may not. And our goal is trying to reduce the chance of these hallucinations. That's been our goal. Now, in the future, will language models address this? Yeah, probably. That's the way technology goes, right? They'll get better and better. Maybe 5 years from now, we'll have language model 2.0 and it'll address this. But for now, that's our goal, is try to reduce the chance of a hallucination. And there's a couple of techniques. Yeah, you read about this, right? Prompt engineering. This is not engineering. Come on, give me a break. It's not engineering. I'm probably somebody who wants to be an engineer, let's call it an engineer in the first place, but it's not engineering, right? So what is engineering? So engineering it's not just solving your problems. Engineering is solving a problem within a set of constraints. That's what engineering is. That's not this. This is a collection of techniques, right? These are the prompt techniques, and I'll give you a few of them, but there's about a dozen, 15 of these. So there's zero shot, where it's like, just take a wild guess. What is Java? Why should I learn Java? Or explain generative AI, or just something real simple. That's called a zero shot. There's no context. Here's the prompt. Go for it. And you might get lucky and get a good response. Like if you ask most of the language models, like, why should I learn Java? You'll get a response that's probably dated. It doesn't include anything in Java 23 or latest Java, because it wasn't trained on that information. So that's few shot. That's zero shot. Few shot is that I'm going to give it some examples, right? And here, this is I'm giving 1, 2, 3, 4 examples. I have some product evaluations from something I built for somebody, and here are some customers saying that this is a fantastic product, I'm gonna give you a 10, or like, Frankie didn't respond to my emails, I'm gonna give you a 0. So you give here, I'm giving it 4. Perhaps you give it 100, 1,000, like you're working for a real legitimate e-commerce company. It could be many thousands here. And here's a couple of new customer comments, and you say, well, how would you rate this? And you ask the language model, given the patterns, what would you rate it? And here, ChatGPT says it's a 2. It's a negative. So it's using your prompt to guide. Your prompt is guiding the language model through the neural networks, getting that result. So it's not intelligence per se. It's using probabilities. Now, chain of thought is a popular one, and it's an important one for an interesting reason. So chain of thought is how humans work, right? We have a problem, we break it down into sub-problems. Then we know how to solve the sub-problems, and then we collect that technique into chain of thought, right? It's how we think of how solving problems. Well, you come up with sub-problems, and you solve the sub-problems. So here, I give it, like, here's how I would solve this one problem about tennis balls and how many I have in each can. It's some convoluted, example. But you give a direction how to think. And then you get a new problem, and you ask it, please think like this. Here, I'm only giving one example, but you could give it 10 examples. Please think like this, and give me the answer. So with a brand new problem. And sure enough, it follows your lead. So this is called chain of thought. Now, the reason why this is really interesting is that there are new types of models out there over the past 6 months called reasoning models. Like OpenAI has a couple, Anthropic has one. They all have reasoning models. So reasoning models use this technique inside the language model. So like, for example, OpenAI, they have the legacy model is called a completion model. It's just a dumb model. Said you give it some text like roses are red, violets are, and you ask it to complete. So it's very, very dumb. It's basically legacy at this point. The next type of model is a conversational model. It's modeled on how humans have conversations. There's actually a paper by Google that explains how humans converse, right? There's a patent on that algorithm too, oddly enough. So these language models use that so-called chat model or a conversational model. This is a new type of model called a reasoning model that uses chain of thought. Now, when you prompt a reasoning model, you prompt it differently than a conversational model. So don't expect the same prompt to work the similar way over different types of language models. So if you use a reasoning model, you wouldn't give it examples because it already knows COT, chain of thought. But if you're not using a reasoning model, then you have to give it examples if you want that type of answer. And there are other types of techniques, but again, it's not engineering, it's just a list of techniques. And the way that you have to look at a prompt is that you have what you want, like your query, you have your query, and then you have context around your query, whether it's examples or how you solve problems. So context is very important. And then you have your actual prompt, and then you have how you want the language model to behave. Sometimes that's called the instruction to the model. Sometimes that's called the system prompt. Some language models have explicit system prompts, and some don't. But you want to tell the model, how do you want it to behave? Well, please respond like a polite Java consultant and assume that I'm a high school student. So couch your response that way. or give me the response in JSON, or give me the response in Markdown. So you're giving it instructions how to behave, like behave as a funny comedian, things like that. So that's your output indicator. So you can think about a prompt being like that. So when you train the neural network, you have a list of nodes, and then as you train it, certain nodes become more likely. And here, like in the bright green, those are more likely than the darker green. And then the gray ones basically are very, very low probability of being chosen. So then you have this like probability, that this sort of like probability distributions fall in this like cloud, right? I like to call it like a probability cloud. So the chances that the language model is going to pick something in that cloud because it's highly likely, right? But if you give it more context, then you're changing the shape of that cloud. You can either make it thinner or wider, but it's how you frame your prompt is the context of the prompt. So now the language model says, well, you gave me more info, I'm going to go this way because of the data you gave me. So what's important, this is critically important, the context to your prompt influences the response that you get back. This is critically important. So the better your context, the better your response. I mean, you might get lucky with a 0 shot. Oh, wow, this is the perfect answer, I'm fine. You might get lucky. It's non-determinism, right? So you can guess at the weather tomorrow too and be correct. There was a nasty storm last night, wasn't it? It woke me up. But you can add context programmatically. So if you're using the API, so you have a prompt from you or your user, and it's like, oh, let me stick this file in there too. Or I'm going to copy paste into the prompt. Or I'm going to take all the text files in this directory, and I'm going to read those text files, and I'm going to stick it into the prompt, and my prompt is going to be this big, and I'm going to send the whole thing to a language model. So you can do that programmatically, but are there other ways? Because if you put all these text files into the prompt, some of those text files or portions of the text files may not be relevant. So you're kind of ruining your context. So there's a better way of doing this. So instead of stuffing things into the prompt blindly, there's a better way. So there's this paper from Facebook research, probably the only thing good that came out of Facebook. Did Frank say that? No, I didn't. So retrieval augmented generation, which is 2020, so it's not that long ago, where we're using traditional IT with generative, with the deterministic IT, with non-deterministic IT. We're now going to use a database. Whoa, this is a classic IT now. So now when we send a prompt up in the upper left, we have a prompt, but before we send it, let's look through the database. So we have anything here that's relevant to what the user is asking. So we go through a database. Well, what did Frank ask? Frank asked about Java. So let's see, is there anything about the latest versions of Java in the database? Let me pull that data out, glom it onto the prompt. So now the prompt, instead of being this, it's now this big. So now you have additional context that you got from a database, right? So sometimes they are so-called vector databases because they're storing vectors. A vector is an array of floats. For us, it's an array of single precision floats. Turns out that AI doesn't care about double precision. So it's an array of single precision floats. And you get that data, so now your prompt is now this big. And you may say, give me the 10 top lines, the 10 most related lines to what Frank asked, and stick them in there. Now stick the whole thing. Now you got really better context. Then the chance of hallucinations is really reduced because you're giving it way better context. So then you send it to the language model, and great completion. So, but with the vector database, and even now that we're using graph databases, which have relationships with the data, which is a really cool enhancement to this, we have so-called chunking strategy. So what does that mean? So in the database, what are you storing? Are you storing entire files? Are you storing sentences? Are you storing paragraphs? Are you storing Markdown? Are you storing HTML? So your chunking strategy varies. Now, it turns out that some are better than others. Like, I started off like learning about sentence, so I wrote a parser that just generated, that broke down text into sentences, and I stored the sentences into the database. But for some things, sentences don't work that well. sometimes phrases work better, and then sometimes a whole paragraph works better, and sometimes an HTML div works fine, and sometimes a piece of Markdown works fine. And it turns out that depending upon the prompt, the chunking strategy behaves differently. And when I worked at Google, one thing we found is that we can change the language model pretty easily, right? Instead of that service, we can use that service. Instead of that service, we can use that service. That was pretty easy. We didn't see that much of a difference. It's very, very nominal. So all the top language models behave very similarly. But what we found was like the chunking strategy affected the success way more often. And it was depending upon the type of the query too. So, and I still think this is an area of research that, well, if I chunk by sentences and the user gives me, or actually if I chunk by paragraphs, that's good for big high-level questions like what's the meaning of life, right? But if you want something like, well, what was the parameter in that method that that's very detailed. So it's a different type of chunking strategy. But this is an area of research. This is all new stuff, right? We're in new territory now. So it's an ongoing research. And I should just a brief thing about embedding, so that's one of my favorite things to teach, is that similarity is how two things are similar. And if you think about, what does that mean? How does the two texts are similar? Well, if you look at two colors, and how do you detect how similar two colors are? How would you do that? What's a good way of doing that? Besides using your eyes. RGB. You have RGB values, right? So then you have basically a three-dimensional, you have X, Y, and Z, right? RGB. And we learned, I think, back in high school how to determine space, the distance between two dots, 2 points in the 3D space. What's the square root of the difference of the squares or something like that? It's like, x squared minus x2 minus x1 squared plus y plus z, square root the whole thing. I mean, it's like testing my high school math. So it's pretty straightforward. Now take that in 3 dimensions, now generate that to, we have 1,000 dimensions, which of course, unless you're an alien from another parallel universe, you can't visualize. So there are algorithms to do that. So embeddings is this long array of floating point numbers. How do you detect if that is similar to another one? That's the embedding space. So when you read about that, that's what that stuff is. And it's really a lot of fun, actually. I mean, recommendation systems use that without doing any generative AI. Like Spotify uses that, and Amazon uses that, and Google uses that. Okay, so the benefits of RAG is that, of course, you have reduced hallucinations, and since you're in charge of the database, so the good thing about this is that you're in charge of the database, you don't have to rely on the vendor to update their model, because they only update it every 9 months to a year, since it's very expensive. They'll update it for you if you have many millions of dollars. So if you're a big enterprise and you want to pay for it, they'll do it for you, but you have to pay. But typically for us, it's every 9 months or 12 months. But with a RAG system, the good thing is that you're in charge of the database. So you can keep it up in real time, right? The bad thing is that you're in charge of the database. So now you have to be a database administrator. Somebody has to do that to track that. So there's good and there's bad with that. And then when you put it in production, so when your manager says, oh, we're going to put a RAG system in production, we're going to do a chatbot, and we're going to take our docs, and we want people to talk to our docs. And it should be really simple, right? So now you want to take something that's static, a static website, and now you want to deploy an app. And we know the difference between putting text on a website and deploying an app is worlds apart. So you have to explain to your managers, like, well, that's cool. I'm glad. I guess I have employment for the next few years with doing this. But then we have to version the prompt. What language model was that talking to? What embeddings did we use? What database version? So you have to track that. Make sure that the users don't type in something nasty. So you have to handle that. You have cost concerns. Now you're sending RAG systems, which a lot of data back and forth. That's going to build up. So all these things in red are things that a tech manager has to worry about. And if you, of course, as a developer, have to worry about this too. And there's some things that are non-technical. Some things that are not technical, like compliance and regulatory, because if you're going to put your company in jeopardy, so if there's a potential of an answer damaging your company, you got to be really careful. And since we're dealing with non-determinism, there's always that chance, right? There's always that chance. So just be very, very careful. And there's frameworks are now coming out to handle a lot of this stuff. And of course, this is basic RAG. There's now advanced RAG. But if you understand this, the advanced RAG is just a riff off of this. Just tweak, a little tweak. Okay, so just a brief talk about chatbots. Okay, chatbots we know, using ChatGPT. ChatGPT is a web app. We know about web apps. It's a web app that front ends a language model in the back end. That's what a chatbot is, right? And sometimes you would want to build something like that. So these generative AI services, they're all stateless, right? We know why, because it helps them scale, right? So they're all stateless. But wait a minute. You said they're stateless, but chatbots remember my conversation. So how are they doing that? I can talk to a chatbot, and it knows what I said the prior paragraph or the prior sentence I said. How did it know that? Well, it turns out what a chatbot is doing is that it's taking your prompt and the responses coming back from the language model and just combining them, just adding them up. So this buffer gets bigger and bigger and bigger so that you're sending the context along with the prompt every time. Now, of course, there's some companies that they've optimized that a little bit. Basically, that's what's happening. You're sending this big chunk of text that gets bigger and bigger and bigger every time. So it doesn't really remember the conversation. You're sending the conversation to it every time. And if your manager says we have to build a chatbot, that's what you have to do. That's exactly what you have to do. Don't assume like, I'm going to use the API, I'm going to have a chatbot. You have to remember this is what you have to do. Okay, so that's what a chatbot is. And for APIs, for Java developers, I mean, of course, the Python programs they're ahead in terms of creating models. But the cool thing about all this, for us, Java developers, is that we went through a period of people or data scientists who want to be a data scientist and we're going to create models. But now we're moving into the production phase. What language do we know that's really good at production systems? That's us. That's us. It's perfect timing. So just when you say people have to learn Python, well, if I create models, it's great. It can connect to C libraries very easily, which Java really can't do. I mean, it's getting better, but it still can't do. I remember doing JNI back in the old days. That was hellish. So hopefully Project Panama, as it evolves, will get better and better. But Python can call C libraries like a piece of cake, right? So that's why it has a huge advantage. So instead of worrying about Python APIs or something called gateways, where you standardize on an API and then you connect these gateways and they will route you to the right language model in the back end, that's more dynamic, but we're not going to talk about that. We're going to talk about just the REST APIs, right? And we know that they're stateless. And okay, so this connects to OpenAI. And again, I just want to show you how easy it is. This is pure Java. You can copy paste this into a joke.java file and run it, as long as you have the key, of course, right? The OpenAI key. And here's the same thing for Google. Now, if you notice between these two slides, this is OpenAI. Whoops, sorry. This is OpenAI, and this is Google. They're similar, but maybe the little thing that I'm setting at the top, that little LLM language, what I'm calling a language, just a bit of JSON, it's slightly different. And now if you're running tests like, well, I want to run it through Gemini, Google, and then I want to run it through Claude, Anthropic, and then I want to use OpenAI's models, you have to constantly change this? That's a headache, right? You don't want to do that. So luckily there's a abstraction. So the folks at LangChain, which is a Python framework for components, right? So LangChain is a Java wrapper around this stuff. So it turns out that it doesn't wrap all of LangChain, but it's turning out to be a really good Java tool. So it started off in life as a wrapper around the Python stuff, but now it's more or less a Java tool. And the basic components, there's a low-level components and a high-level components. The low-level stuff is like how do we deal with prompts and models and how we deal with RAG systems. And then there's high-level services called services in LangChain for J. I would recommend when you learn this stuff, use the low-level things. Use the low-level APIs. And spend like a week building your own chatbot using the low-level APIs before you jump to high-level ones. Because I found that if you understand the low-level, then when you use the high-level, you know exactly what's going on, and you have a deeper understanding. So when you put these things in production, you understand what's going on. And it's not hard. I mean, 2.5 years ago when I built my first chatbot using some of this stuff, since I play guitar, I took transcriptions from one of my favorite guitarists, and I went to his YouTube. I got all the transcriptions for YouTube. I got his tutorials. I got all this stuff. I got megabytes of training material, and I created my own chatbot. And then it's as if I was talking to my favorite guitarist. And I said, over this chord progression, what would you play? And of course, it answered as if it was him, and it gave me like what notes to use based upon his style. So I went through that, and once I understood how well it worked, then using services was like, oh. It just makes the programming a little easier. But use a level, just for a little while to understand how this works. All right, so here's an example where I'm using a chat language model, chat language for OpenAI. And once I have the handle to the model, after that first part, all the rest is LangChain for J. I'm not dealing specifically with any OpenAI stuff. Right, once I have that abstraction, it's fine. And here's, this is the same thing, but with a system message, with an instruction. Here's Claude, the Anthropic. So once I have the handle to the model, all the rest is LangChain for J. I don't have to deal with specifics of any particular model. Of course, this is useful, right? Especially when you're testing things. Okay, so now where do we go next? So now you know the basics. So when you go read about this stuff, you say like, oh, I know the basics now. Okay, advanced RAG, what does that do? What's this? Basically what RAG does, except there's little tweaks. Context, now you know what context is. Now what's next? So the first thing is that, when do I use this stuff? Okay, after you've broken down task into subtasks, which we all do on a regular basis, is there a high risk that if the results are incorrect or wrong, are they really high? Is my company in danger from like risk reputation or financial? If there's high risk, guess what? Don't use it yet in production. It's not ready, okay? But if there's not high risk, let's say, do you have patterns? Does your problem require patterns? Does it have any patterns? If the answer is no, why are you considering machine learning? Use a SQL query. Not all use cases require this stuff. If there are no patterns, don't use it. If you have patterns, then you have to decide, okay, firstly decide whether you want predictive AI or generative AI. Then you say like, okay, well, now I'm at the bottom. Are there ethics issues? Because there's now governance and there's laws. And in Europe, there's serious laws. Okay? Then you have to deal with legal. Talk to your legal department. And should we put this in production or not? Now, in terms of next generation, we know all about the plugins. We know about Copilot. We know about the plugins for IntelliJ, and I just heard one for NetBeans. So there's all these cool plugins that you can have. Now, there's these two interesting products, or there's Cursor.com and Klein.bot, sort of like looking at, well, how does the IDE of the future look like? Now, they're not perfect. This is like early views of what the future might be, but it's interesting to try these, to see like, okay, well, how would I use AI? If I were to use AI all the time for every phase of software development, not just for code generation, but every phase, these are things that are saying like, this is possibly the way of the future, right? And another thing is that, so something that we learned back with SQL, there was, injection. We had query injection. And we solved that problem, all right? We had what, templates, and so we got around that problem. You can't use that solution for language models. We haven't solved this problem yet. So you can architect around this problem, right? And so instead of allowing the user to put in a pure prompt, get the prompt from the user, you better massage it first before you send it to the language model, right? Or you may massage it, say like, send it to that language model. Oh no, send it to that one, or send it to this one, right? We're using a collection of language models. So really, you're using a bunch of collaborating language models. So think of like language models as just one tool to use. But if you use a collection of them, you can have 3 of them generate results. You have the 4th one. Which one was the best one based upon this criteria? Use that one, right? So, but we haven't solved this yet, so it's a serious problem. And my concern is that, with the next generation agents, right? So with agentic technology, where we have a lot of these, instead of us controlling the AI, it's doing stuff on its own. So I worked for an investment bank back in 2008. You might remember what happened when we had no safeguards. I'm just saying. I'm just saying we should be cautious. That we have, how many of you would drive in a fully autonomous, a quote, fully autonomous car on the highway with your kids? Why does Tesla have the highest fatality rate of any car? So we're still early days. They're still early days, right? So hopefully we solve these problems. And I know some of my friends in the cybersecurity are attacking this problem. My brother's a cybersecurity person, and he's like, this is a huge problem that we're trying to deal with right now. So these are things for you to keep in mind. So with that, hopefully you're on the right track. So the next thing is just like, what are the prompt techniques? What advanced RAG things? But this is the basic. And it doesn't just apply to code generation. It applies to everything going forward. So thank you.